So in 6.1, we talked about discrete uniform distributions and how that transitioned into continuous uniform distributions. So again, an example of a discrete distribution would be rolling a 10-sided die, and you either roll a 2, you roll a 4, or you roll a 7, right? Very discrete values. You cannot roll a 2.3, right? It's not an option on a 10-sided die. And so we transitioned from a discrete uniform distribution into a continuous uniform distribution. And in the continuous uniform distribution, you can have decimal values and fractional values and values in between the whole numbers. And so the example we had here was waiting for a subway to arrive, and the subway arrives every 10 minutes. And so there's a possibility that you may be waiting 2 minutes or 4 minutes or 7 minutes, or maybe 3.4 minutes. And so this was a continuous uniform probability. Continuous because every value along the x-axis is available, and uniform because every value had the same probability of occurring. So in dealing with a continuous uniform probability distribution, we noted a couple things. Number one, notice that the shape is a rectangle, and this rectangle has a base. So this is the base of the rectangle. In our case, this base is 10 units because there's 10 minutes there. There is also a reciprocal relationship between the base and the height. The relationship is that the height is 1 over the base. So in our case, the height of this rectangle is 1 over 10. 10 is the base, so the height is 1 over the base. And the reason that this relationship exists is because the area of this rectangle has to equal 1. It has to equal 1 because it's a probability distribution, and the sum of any probability distribution is always equal to 1. So if your base is 10, the height of the rectangle has to be 1/10. On the other hand, if your base is 32, then the height of your distribution has to be 1 over 32. It's always a reciprocal relationship. So that way, when you multiply them together, you get 1. So going back to our original content on this one, we said that the base was equal to 10. We said that the height was equal to 1/10. We knew that the total area was equal to 1. And then we could ask questions about the probability of specific events. For example, we could say, what is the probability that you have to wait between 3 and 7 minutes? So what that means is, what is the area of the region bounded by 3 and 7, a lower bound of 3 and an upper bound of 7. So our base changes from 10 to 4 units in this case. So with this rectangle, the area is going to be the base times the height. And in our case, the base is 4. The height does not change. The height remains the same, 1/10. So that becomes 4/10, which is 0.40, which is 40%. Suppose the time it takes Lizzie to eat an apple is uniformly distributed. So that's important to identify. We're dealing with a uniform distribution. So it's uniformly distributed between 5 and 10 minutes. So if we were to make a graph of this, here's our axis. Our lower bound would be 5 minutes, and our upper bound would be 10 minutes. And we could draw a rectangle because we know it's uniformly distributed. And the height of this rectangle, if we know that the base here is equal to 5 units, 10 minus 5 is 5, then we know that the height is 1/5. In this drop-down menu, you're going to select the letter U. Your lower bound is going to be 5. Your upper bound is going to be 10, because that is the lower bound and upper bound of the information that they gave us. Okay, the next question. What is the probability that it takes Lizzie at most 4 minutes? At most 4 minutes means 0 minutes, 1 minute, 2 minute, 3 minute, up to 4 minutes, at most 4 minutes. Well, the answer to this is 0. Our minimum for the data given starts at 5. What is the probability that it takes Lizzie less than 8.6 minutes? So that means on our graph, we need 8.6. And we can draw a little line here like this. And what we would like to find is, what is the area less than 8.6? What is the area of this rectangle? And so to find this area, we have to do two things. Number one, find the base. So if you subtract these two, you get 3.6 as the base, right? And then we have to multiply the base by the height. So we're going to take 3.6 and multiply it by 1 over 5, 0.72. So this area is 0.72, which means there's a 72% probability that Lizzie will finish the apple in less than 8.6 minutes. What is the probability that it takes Lizzie between 6.5 and 9.5? So that means we're going to have a 6.5 right here. We'll have a 9.5 right about here. We'll get rid of this stuff. So we've got a lower bound of 6.5, an upper bound of 9.5, and we would like to find the area of this rectangle. Now, again, we need to find the base. And so in this case, our base is going to be 3 units, and our height, once again, does not change. So it's going to be 3 times 1/5, which is 3/5, is 0.60, which is 60%. So there's a 60% probability that will take Lizzie between 6.5 and 9.5 minutes to finish eating the apple. Now, the next question says, what is the probability that it'll take Lizzie fewer than 6.5 and more than 9.5? So now what we're talking about is fewer than 6.5, which would be this region, and greater than 9.5, which would be this region. And you could calculate each one of these independent, or if you're clever, you'll recognize this is the complement to the green region. And so instead of calculating these individually, let's just take the complement of the 0.6 and we get 0.40.